You are sitting on a train waiting to leave. Suddenly, the train beside you begins to slide backward. Then you realize the horrible truth. Your train is the one moving, and it started so gently you never felt a thing. That confusion is not a mistake. It is a law of nature. Newton's first law says that once you move at a steady speed in a straight line, there is no experiment on Earth that can tell you that you are moving at all. This idea has a name, the principle of inertia. It was first realized not by Newton but by Galileo decades earlier, though Newton never acknowledged that debt. Newton cared deeply about how to phrase this law precisely. He wrote it in Latin and rewrote it many times until he settled on the words we now translate as follows. Every body continues in its state of rest or of uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. Read that carefully. Rest and uniform motion are placed side by side as if they were the same kind of thing. That is the deep claim hiding inside the first law. Newton illustrated his law with three pictures. First, a projectile. A thrown object continues in its motion except that the air slows it and the gravity pulls it downward. Left alone, it would sail on forever in a straight line. Second, a spinning top. Its parts are continually drawn aside from straight line paths by the cohesion holding the top together. And that is exactly why it keeps spinning rather than flying apart. It does not stop except as the air rubs against it. Third, the planets and the comets. These greater bodies move through freer, emptier space, meeting almost no resistance, and so they preserve their motions, both straight and circular, for a very long time. In every case, the pattern is the same. Motion persists. What we notice is only whatever eats away at it. Now here is what makes the first law genuinely scientific. It is not a definition. It is an experimental statement about how real bodies move. It says this: when a body moves with constant velocity, one of two things is true. Either no forces act on it at all, or the forces acting on it add up to exactly zero. Constant velocity and zero net force are two names for the same situation, and the reverse holds too. If a body changes its velocity, then it has a non-zero acceleration, and so the total force on it must be non-zero as well. There is no such thing as a velocity that changes all by itself. A change always points to a force. And when a velocity does change, look closely at what can change. Velocity is not just how fast, it is how fast and in what direction. So a body's velocity changes if its direction changes, or if its speed changes, or if both change at once. Turning a steady corner is a change in velocity, even at constant speed. Speeding up in a straight line is a change in velocity. Either one demands a force. This is why the first law is really a law about acceleration in disguise. So let us go back to that train. After it starts, the acceleration is often so small that you can barely perceive it. And so you get startled. It looks for all the world as if the station is sliding backward while you sit perfectly still. Newton's first law tells you something humbling about that moment. There is no physical way to decide who is really moving, not because your senses are weak, but because the total force acting on you is very nearly zero, and the zero net force means constant velocity, which is indistinguishable from rest. Once you reach a steady cruising speed, your mind quietly dismisses the whole thing. The ground moving backward? Impossible, you think. But physically, there is no actual experiment that tells you whether the train is moving or the ground is. That impossibility is not a nuisance. It is one of the most important truths in all of physics. If rest and the constant velocity really are indistinguishable, then the laws of motion must look exactly the same, whether you are standing on the platform or gliding past it on the train. Any such point of view moving at constant velocity is called an inertial reference frame, and inside every one of them, physics is identical. So the first law does more than describe a lonely object drifting through space. It tells us who is allowed to do physics, and the answer is everyone moving steadily. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.